Hello guys, good afternoon, welcome to my channel. Today I will be looking at the analysis of linear motion. This particular topic in physics is very important, and what we are to do here when we talk about analysis of motion is to discuss the equations of motion. Now we are given that a body has an initial velocity u and it's moving in a time t. If the body's velocity is v and its acceleration is a, as it covers a distance s. Now, these parameters, initial velocity, the time taken, the final velocity, the acceleration, and the distance. The distance s, these are the properties of a body that is performing a uniform linear motion. When a body is performing a linear motion, the whole of the things you can talk about the motion is its initial velocity, its time, the final velocity, the distance covered, and its acceleration. Now, with this, we have three equations that we need to look at. The first one states that V equal U plus AT. And the second one states that S equal UT plus half AT square. And the third one states that V square equal U square plus 2AS. These are the three equations that we want to analyze together. Now let's start. From the definition of acceleration, we have that acceleration of a body is given as the change in velocity, that is v minus u, all over what? The time taken. If I cross multiply here, because we are trying to achieve the first equation here, if I cross multiply here, I will have that AT equal v minus u. Now, I have to make what? V the subject of the formula. So, I will have to take u to the other side, or you add u to both sides. So, we have that V equal u plus AT. And this gives us the first equation of motion. Now, I'll quickly discuss when to use this particular equation before we go to the next equation. Now, when are you to use this equation? You are to use this equation when distance is not required. That is, when you are asked to determine a certain property about the motion, but without a distance. Now, in this case, they might ask you to calculate for the final velocity. Initial velocity is given, acceleration is given, and time is also given. So you can make use of this equation. And at times, your body can start from rest. If the body starts from rest, the initial velocity will become what? 0. Then you can have your what? Final velocity to equal what? AT. But at every point in time, for a body that is undergoing what? A motion, the body will surely have what? Acceleration and time. So, let's quickly move to the second equation. How can we get this second equation? You and I both know that when a body is moving with what? Non-uniform velocity, for us to get the velocity of such body, it has to be what? Average velocity. Now, from average velocity formula, we have that the distance covered, which we can regard as a displacement, equal the final velocity plus the initial velocity divided by time. Divided by 2 multiplied by time. So if we have this, now from this equation here, we can replace the V in this particular equation with what? U plus AT. So S becomes U plus AT plus U times TL divided by 2. Then if I open this bracket, I have that x equal 2ut plus 8t squared. Now I can now what? Split this what? 2 for the two equations. Sorry, for the two part of the expression. So if these two should cancel this, I will have that s equal ut plus 1 over 2 8t squared, which happens to be the second equation of motion. Now, when I need to use this particular equation, I think you can see the way we got it now. It's as simple as that. Now, when I need to make use of this equation, you have to use this equation when you are dealing with the properties of the body in motion without the final velocity. When you are not discussing the final velocity, then you can talk about this particular equation in which you are required to look for distance. In most cases, this equation is always used for a body that starts from rest. When the body starts from rest, the initial velocity usually becomes what? 0. So this one will become what? 0. Then you have that s equal half at squared. Though, when we start solving questions under this particular topic, we shall what? Talk more about the equations. Now let's go for the third one. Before we go to the third one, I would like us to go back to this particular equation here, that is the definition of what? Acceleration, where we have a to equal v minus u over t. Then we are going to make t the subject of the formula from this particular equation. So if we make t the subject of the formula from this equation, I will have that t equal v minus u over a. Then I'm going to slot this t into this particular equation there, the average speed formula. If I slot t into this equation, the other time I slot v into this equation. So in this time around now, I'll be slotting for what? T. Then this equation will become s to equal v plus u over t multiplied by v minus u over a. If I use these brackets to open each other, I will have that s equal v times v, that's v squared, v times u minus uv. And this times this, we have plus uv, then this times this minus u squared, divided by 2 times a, that's 2a. Now, you know that negative and positive will naturally cancel each other. So, this and this will naturally cancel. Then I will have that s equal v squared minus u squared over 2a. Now in this point in time, you know where we are going to want to achieve v squared equal u squared plus 2s. Then I can cross multiply it. If I cross multiply there, I will have 2as to equal v squared minus u squared. Hence, v squared equal u squared plus 2as. That is the equation required. So this particular equation now, when can we make use of this? Good. We can make use of this equation if we are given every properties of the equation but the time is not given. When you are given the properties of the motion but the time is not given, and you are required to look for either the final velocity, initial velocity, or acceleration, or the distance, then you can make use of this equation. Why? Because time is not given in the question, and this particular equation has nothing to do with what? Time. Now, I would like to quickly explain the parameters that we have in this question. U, which is initial velocity. When a body starts from rest, the initial velocity usually becomes what? 0. Except in the case of when the body is retarding. The time taken is measured in seconds. And I'm going to tell you something about the time also. The time usually being a tricky word aspect of question in motion. Should in case, if you are given that time is in what? Let's say time is given in nth second. If you are given time in nth second, you have to be careful in this case. Let's take for instance that your time is given in nth second and you are looking for what? You are looking for distance covered. Your distance covered is going to be S equal Sn minus Sn minus 1. Let me quickly cite an example here. Let's say I have my time to be third second. So the distance that I'm calculating for at third seconds is like me asking that what was the distance covered by the body in the last 1 second. So in a nutshell, if you are given what time in nth second, what it simply means is that what is the time, what is the distance covered, or whatever you are calculating for, what is the value of that in the last 1 second. So if I'm calculating for distance and I have my time in nth second, it means what was the distance covered in the last 1 second. So if the time is 3 seconds, then I have to calculate for distance when the time is 3 seconds. Then I will take the difference of it when the distance is what? When the time is 2 seconds. So the distance covered in 3 seconds minus the distance covered in 2 seconds will give me the actual distance I'm looking for. And should in case I'm asked to calculate for velocity, maybe in 3 seconds, it will also be V equal the velocity of the body in 3 seconds minus the velocity of the body in 2 seconds. Now class, if I may ask you, if you are given that the time is 8 seconds, what will be the velocity and what will be the distance if you are asked to calculate for? Thank you. Your distance will become what? The distance when the time is 8 seconds minus the distance when the time is 7 seconds. And if it is velocity you are looking for as well, it's going to be the velocity when the time is 8 seconds minus the velocity when the time is 7 seconds. And I think we understand that. So we are not talking about the final velocity. Normally, the final velocity cannot be 0 except if the body is retarding. When I say a body is retarding, it means the velocity is reducing. When a body is accelerating, the velocity is increasing. So in a case whereby you have 0 velocity, then it means that the body velocity is reducing. And that is the case of what? Retardation, or you call it deceleration. Then you have your acceleration. Acceleration is the increase in velocity, the rate at which what? Velocity increase. For instance, if I have my acceleration to be 2 meters per second square, this simply means that for every second, the velocity is increasing by 2. Take for instance that the velocity of a body is 4 meters per second and its acceleration is 2 meters per second square. It means for every second, the velocity is increasing by 2. So this one will become 6, then 8, then what? 10, and so on like that. So acceleration is literally the increase in velocity per second. And the distance is what? The path traveled, the length that you covered when you traveled. That is what our distance simply what implies. Now, if you like this video, I would like you to subscribe to this channel. If this particular lecture has in any way what assist you or help you, kindly hit on the like button and subscribe to this channel. It will motivate me to produce more video on physics and mathematics. And mind you, when a problem becomes difficult, all you need to do is to change your perspective. Thank you.